Archaeologists are baffled by what Puma Punku was, how it looked, and what the purpose of this enormous structure would have been.
In the high plains of Bolivia, Puma Punku stands as a testament to ancient engineering that defies easy explanation.
The mysterious ruins of Puma Punku, nearly 13,000 feet in the Altiplano of Bolivia.
Its massive stone blocks, carved with razor-sharp edges and interlocking precision, have puzzled experts for centuries. How could people nearly 1,500 years ago achieve such exquisite craftsmanship with primitive tools? Recent breakthroughs using advanced 3D scanning and microscopic laboratory tests are beginning to unveil secrets that challenge traditional ideas about stonework. What if these enormous H-shaped blocks weren't just carved, but cast using a sophisticated, now lost technology? The story of Puma Punku's stoneworkers might rewrite the history of ancient innovation. The mystery of the H-blocks. Puma Punku's H-shaped stone blocks are among the most enigmatic relics of ancient engineering, sparking awe and puzzlement for decades. Carved from dense andesite, these massive stones fit together with a precision so exact that, according to local tradition, not even a razor blade can slip between their joints. This remarkable tightness persists despite centuries of weathering, seismic activity, and human interference. Archaeologists and engineers alike have marveled at the razor-sharp edges and uniform slots that characterize each block, challenging conventional ideas about prehistoric craftsmanship. The geometric complexity of the H-blocks is also striking. Each piece is not merely rectangular, but sculpted with intricate notches, grooves, and protrusions, designed to interlock like large three-dimensional puzzle pieces. The modular nature of the blocks suggests an advanced understanding of structural mechanics, where stability relies on precise spatial relationships. Such design enables the platform walls to resist gravity and seismic tremors, pointing to construction techniques that go beyond simple stone stacking or carving. What makes Puma Punku's precision even more confounding is the apparent absence of traditional tool marks on many surfaces. The official narrative supposes that these blocks were painstakingly hand-carved using hammerstones and bronze chisels around 1,500 years ago. But how could such fine, consistent geometry and flawless right angles be achieved with crude tools? This analytical gap fuels ongoing debates and deepens the mystery behind the builder's methods. Over time, some have suggested that lost or forgotten technologies could explain this extraordinary craftsmanship. The local Aymara oral tradition recounts tales of stones that once flowed like water, soft enough to be molded by hand before hardening into rock. While some dismiss these stories as metaphoric expressions of admiration for the site's artisans, others see them as hints toward an unfamiliar form of stone fabrication, perhaps a form of early stone casting. This enigma is heightened by the current state of the site. Puma Punku today no longer appears as the unified ceremonial platform it once was. Instead, it lies broken and scattered. Despite this, the scattered H-blocks provide a direct link to the skill and intention of their creators, challenging archaeologists to reconstruct not only the physical layout, but the processes behind their production. The scattered ruins also offer clues to the monumental human effort necessary to quarry, transport, and assemble stones, some weighing over 100 tons each. How did ancient builders achieve this feat? The original arrangement of the H-blocks has been lost to time and modern destruction, but the precision of the individual blocks leaves a lingering question. Was their perfection a byproduct of carving, or evidence of a different, more sophisticated technique? This question persists, inviting deeper investigation into the origins and fabrication of these stones. Knowing the answer could rewrite our understanding of the capabilities of pre-Columbian Andean civilizations and their mastery of materials and engineering. The deeper mystery behind Puma Punku has thus quietly beckoned modern science to look closer, armed with new tools and curiosity. While the exact techniques remain elusive, Every observation underscores a timeless truth. Puma Punku's H-blocks embody an extraordinary fusion of artistry and engineering. Their precision and durability continue to provoke a mix of wonder and healthy skepticism, an enduring testament to human ingenuity lost beneath centuries of forgotten history. The secrets of the H-blocks cannot be fully appreciated without considering the rich cultural and historical context that shaped Puma Punku's rise. A story layered with archaeological discoveries and radiocarbon timelines that ground these mysteries in time. Puma Punku's historical context. Puma Punku is inseparably linked to the ancient city of Tiwanaku, an archaeological complex that flourished on the Altiplano, just southeast of Lake Titicaca. The name Puma Punku means door of the puma in Aymara, evoking powerful symbolism connected to the puma as a guardian figure. This site forms part of the larger ceremonial and political hub centered on Tiwanaku, reflecting the culture's cosmology and architectural innovation during the first millennium AD. While the massive stone blocks themselves defy direct dating, the chronology of Puma Punku's construction is anchored through radiocarbon analysis of organic materials buried beneath the platform. Charcoal, plant remains, and bones found in the mound provide a robust chronological framework, placing the first major building phase between AD 536 and 600. This period aligns with Tiwanaku's earliest monumental construction surge, marking Puma Punku as a foundational element in Andean civilization. Over decades, increasingly sophisticated Bayesian modeling applied to hundreds of radiocarbon dates from Tiwanaku and surrounding sites has sharpened the timeline for Puma Punku.
But it looks like it's done with modern tools.
The precision of the cuts on the stones is amazing, considering how long ago this was built.
Recent datasets from 2023 further tightened the confidence intervals, confirming Puma Punku's role in a continuous building effort across the region throughout the first millennium. This timeline reveals a society investing significant resources and expertise into creating monumental ceremonial architecture. Excavations at Puma Punku and the broader Tiwanaku complex continue to yield surprises, reinforcing the evolving narrative of the site. In 2024, the discovery of the Palaspata Temple revitalized scholarly attention, hinting at undiscovered layers of ceremonial infrastructure buried beneath the Andean soil. This ongoing research underscores how much remains to be uncovered about Tiwanaku's architectural and cultural development. Grounding the Puma Punku mystery in the historical context means that the site was not a single wonder, but a part of an urban and religious center with a high level of sophistication. The ceremonial platform was a symbol of the union of political power, spiritual ideology, and technological prowess. Knowing its timeline makes us connect the craftsmanship of the H-blocks to a cultural narrative of tireless building and innovation. This greater context has also opened up the significance of Puma Punku in the pre-Columbian history. The site's construction matched with the times when the Andean highlands were gradually integrated socially and politically, which ultimately shaped the highlands for the next centuries. Knowing the stones in this context elevates our view of their technical complexity as mere symbols of cultural identity and ambition. Linking the site to a specific time also raises questions about the methods of construction and the logistics involved. Looking at the size and weight of the stones, and also their precision fitting, the question of how such extraordinary feats were achieved with the tools and the organization of the society at that time becomes more emphasized. The difficulties posed to the builders make the mystery even more intriguing as to how the outstanding results were attained. With the history and archaeology bases established, the focus now shifts to the damage and disruption that Puma Punku went through long after its glory days, a chaotic affair that spread its stones and made their original position hard to decipher. Grasping this destruction is vital for understanding the digital reconstruction project of the huge legacy that is ongoing and the efforts that is being put into it. The scars left by time and human activity add urgency to the quest for answers, prompting researchers to leverage modern technology to recover what history nearly erased: site damage and reconstruction efforts. By the late 19th century, Puma Punku had already begun to lose its cohesion and dignity under a barrage of human intrusion. As Bolivia's railway network expanded, laborers used dynamite extensively to clear paths, inadvertently wreaking havoc on the ancient site. Massive carved stones were blasted, toppled, broken, and sometimes hauled away to serve as ballast for tracks and bridges. This destructive period devastated portions of Puma Punku, dismantling carefully fitted blocks and scattering them across the plain. Contemporary accounts from railway workers and travelers describe a chaotic scene, where the reverence for the ruins gave way to practical concerns and opportunism. Blocks that had once formed integral parts of ceremonial architecture were treated as mere building materials. This reckless scavenging severely damaged the platform and its distinctive H-blocks, leaving their original arrangement almost entirely lost. In the decades that followed, archaeologists faced the daunting challenge of studying a site fragmented and displaced by centuries of neglect. The jumble of stones, often overturned or broken, obscured the logic that once united them. Without intact structures, many questions about Puma Punku's construction and purpose remained locked away, hidden in the relations between disconnected pieces. Fortunately, advances in digital technology began to offer new hope. Starting around 2018, teams from institutions like UC Berkeley embarked on ambitious projects to scan each documented block in high resolution. These scans were then used to produce precise three-dimensional printed models, scaled and accurate to the millimeter, allowing for a forensic-like investigation into the original geometry and potential arrangements. Early attempts at virtual assembly revealed the difficulty of working with outdated site maps and incomplete records. Many blocks initially refused to align, and the characteristic T-shaped structure remained elusive. Only after painstaking recataloguing and correcting the orientation of several key pieces did the virtual reconstruction start to resemble Puma Punku's original form. This breakthrough demonstrated that despite the chaos, the stones remained components of a carefully engineered system. More recently, from 2024 into 2025, the ID Labs campaign pushed digital reconstruction further with advanced drone photogrammetry and terrestrial laser scanning. This effort produced a near-perfect digital twin of Puma Punku, with sub-millimeter accuracy capturing every fragment and surface detail. Such detailed models enable researchers to test various engineering hypotheses that would otherwise be impossible in a ruined, unapproachable field site. Within this digital environment, subtle features, like the modular arrays of the H-blocks and their fenestrated gateways, become clear. Computational simulations of gravity and seismic forces show how the interlocked stones would settle stably, echoing the enduring resilience of the original platform. Machine learning analyses even reveal hidden symmetries and proportional systems, suggesting a sophisticated spatial order in the design. These efforts have not only revived lost architecture, but forged a powerful new method for archaeological inquiry, one that blends art, science, and technology to unlock mysteries buried by time and damage. Yet even with these digital triumphs, a key question remains unresolved. How were such precise blocks actually made? The mystery of Puma Punku's craftsmanship reaches beyond assembly, beckoning us to probe deeper into the very nature of the stones themselves and the techniques their creators employed: engineering and structural design. Puma Punku's construction reveals a remarkable mastery of engineering far ahead of its time. The famous H-shaped andesite blocks were not mere decorative stones, but vital structural components engineered to interlock in 3 dimensions. Each block features a series of notches, grooves, and projecting lugs, enabling them to fit together like precision puzzle pieces. This modular design created stable walls and platforms capable of withstanding both the force of gravity and frequent seismic activity on the Andean plateau. The builders maintained absolute right angles across block faces, and the parallel slots were carved to uniform depths and widths, ensuring that each stone mated almost seamlessly with its neighbors. This extraordinary attention to detail is not only a testament to skilled craftsmanship, but it also reflects a deep understanding of how shapes and forces interact to create stability. The geometry of the blocks was both functional and aesthetic, allowing the entire platform to resist natural shifting and settling over centuries. Beneath these carefully shaped stones, a sophisticated foundation system further anchored the entire structure into the bedrock. Massive sandstone slabs, some weighing more than 100 tons, rested inside leveled trenches cut into the ground. In several areas, tongue and groove joints locked the foundation stones together, distributing load evenly and preventing lateral movement. This technique was especially crucial in the earthquake-prone Altiplano region, where shifting earth could easily collapse less robust constructions. One of the site's more surprising features is the use of metal clamps embedded between blocks. Excavations have uncovered traces of bronze staples shaped like eyes, cast from a copper-tin alloy and fitting precisely into cut sockets. After being poured into these recesses, the clamps were hammered flat to bind the adjacent stones securely. Metallurgical analysis revealed the presence of arsenic, an element characteristic of pre-Columbian Andean bronze technology, confirming sophisticated metallurgy deeply integrated with masonry. These metal fasteners speak to a deliberate strategy to reinforce the platform, reducing the risk of separation during storms or seismic jolts. Through this combination of mechanical interlocking and metal reinforcement, the builders created a structure designed to endure extreme conditions. The distribution of load across multiple contact points lessened the strain on any single joint, resulting in an installation that has stood the test of time. Recent advances in digital archaeology have provided further validation of Puma Punku's engineering brilliance. High-resolution photogrammetry and three-dimensional models produced by research teams confirm the interplay of modular H-blocks, keyed foundations, and metal clamps. These tools reveal a careful balance of rigidity and flexibility, a platform both robust against collapse and adaptable to natural ground shifts. The complex was clearly engineered with a precise, repeatable system, not a random or ad hoc assembly of stones. This challenges assumptions that ancient builders worked exclusively with rudimentary techniques. Instead, it points to a profound mastery of material properties and structural principles, achieved with surprisingly simple tools but deep knowledge. As the digital and physical evidence accumulate, one truth becomes increasingly clear. Puma Punku was constructed not only for ceremonial or symbolic purposes, but as an architectural masterpiece, blending art, science, utility in ways that remain impressive even by modern standards. This intricate marriage of design and durability raises another vital question. What materials and manufacturing processes allowed such exacting results? The answers lie deeper still, in the very composition of these enigmatic stones. Laboratory discoveries on stone composition. Recent scientific investigations have uncovered startling clues about the very materials Puma Punku's builders used, challenging the long-held belief that the blocks were simply quarried and carved natural stones. Detailed analyses using scanning electron microscopy have revealed that the sandstone slabs, some weighing as much as 130 tons, contain chemical signatures inconsistent with nearby geological formations. Notably, these stones show elevated levels of sodium carbonate, also known as natron, a substance not found naturally in the Altiplano's local geology. This discovery hints at a material that may not be purely natural, but rather crafted or modified through an ancient chemical process. The sodium carbonate acts as a flux, lowering the temperature needed for geopolymerization, a reaction that transforms a malleable paste into a dense, durable stone-like material. Such technology, known from ancient Egyptian mortars, involves mixing sand, volcanic ash, natron, and water into a moldable blend that cures into solid rock, sidestepping the difficulties of quarrying and transporting massive monolithic stones. Lab-made replicas created with these components mirror many physical qualities of Puma Punku's original blocks. When subjected to X-ray diffraction and electron microscopy, these synthetic stones exhibit similar density, durability, and microstructural features, the so-called amorphous binder phases, that indicate chemical reactions cementing the composite. The striking parallels between laboratory-produced geopolymer stones and the Puma Punku blocks support the hypothesis that the builders used a form of early artificial stone casting. This casting theory also offers explanations for puzzling facts about the site's stones: the razor-sharp edges, the uniform block faces without obvious tool marks, and the razor-thin joints. Unlike natural sandstone, which fractures unpredictably, these blocks have crisp, consistent edges that look as if they were formed in molds rather than chipped from raw rock. This notion pushes the boundaries of what we traditionally think ancient technology could accomplish. Yet, skepticism remains. Critics point out the lack of discovered molds or casting equipment on site, and speculate natron could have arrived through trade or later contamination. Despite these doubts, the compositional and microstructural evidence stands strong, positioning this theory as a major breakthrough in understanding Puma Punku's construction. Further intrigue surrounds the site's andesite H blocks, whose lab analyses uncovered unexpected organic compounds. In 2019, researchers detected nitrogen and carbon signatures within these volcanic stones, hinting at the inclusion of organomineral binders, substances possibly derived from plant extracts or animal products mixed with volcanic powder and water. Such a mixture could have formed a castable paste, adding another layer to the site's technological sophistication. Replication experiments at the Geopolymer Institute demonstrated that blending carboxylic acids, guano, and local clays produced material nearly identical in microstructure and mechanical strength to the ancient blocks. These results provide compelling evidence of a technique far advanced for its time. However, controversy persists as others question the validity of detecting organics in volcanic rock long exposed to the elements. To validate these findings, multi-laboratory blind testing is underway, probing the presence and age of organics using rigorous protocols. Depending on these results, Puma Punku may represent the earliest large-scale geopolymer technology in the Americas, rewriting the narrative of ancient material science. As these discoveries unfold, they deepen the mystery and grandeur of Puma Punku, showing that beneath its shattered stones lies a story not only of architectural brilliance, but of chemical and technological mastery awaiting full revelation. The casting hypothesis, one of the most provocative theories to emerge from recent research, suggests that Puma Punku's famed H-blocks were not carved from quarried stone, but cast, created from an ancient form of geopolymer concrete. This idea challenges thousands of years of archaeological assumptions, proposing that builders mixed local sand, volcanic ash, and a key ingredient called natron, or sodium carbonate, with water to form a moldable paste. Once poured into wooden or stone molds, this mixture hardened into durable blocks, bypassing the immense labor involved in quarrying and transporting massive stones. Lab experiments have replicated this process with striking fidelity. Under scanning electron microscopes, the artificial stones match the density, durability, and microstructure of Puma Punku's originals almost perfectly. A distinctive amorphous binder phase, evident in both the ancient blocks and lab samples, points to a chemical reaction consistent with geopolymerization. a technology known from ancient Egyptian mortars, but previously unconfirmed in the Andes. This blend of materials forms a stone that, while man-made, can last millennia like natural rock. Casting provides reasonable explanations for the most puzzling questions about the Puma Punku site. As for instance, the H-blocks, with their extremely uniform and even faces and razor-sharp edges, are one of those situations where it is very difficult for any traditional carving technique to match the quality that might result from mold formation. Besides, the very few surfaces with tool marks can more easily be attributed to a molding process than chiseling. The high level of precision that would be required in casting would also mean that the development of perfect-fitting joints, crucial to the earthquake resistance of the structure, is not a problem at all. The skeptics did not take it lightly, and they pointed out the absence of molds or casting tools at the site as evidence against the casting theory. They also suggested that the natron found might come from different sources like trade, contamination, or modern testing influenced by the environment. Still, the compositional evidence, especially the unexpected chemical signatures in the sandstone, is very strongly in favor of a casting process argument. It suggests the once thought-out lost technologies of ancient Andean civilizations. This was made even more credible by the discovery of microorganismic compounds in the andesite H-blocks. Such findings pose questions regarding the usage of organo-mineral binders, i.e., plant extracts or animal residues could have possibly been included in the mix just to make it more workable or to quicken the setting. Replications formed in such a way that they included compounds like carboxylic acids, guano, and local clays, produced stones that were even in microstructure and strength to the originals, thereby pointing to a refined, intentional recipe. Nevertheless, a battle of hands continues. Critics' main focus is on the reliability of organic residue detection that is being questioned, and they cite possible contamination or instrument error as the reasons. A single laboratory's results are not enough to dethrone the consensus that has ruled for decades and that held these stones were made through protracted cutting and chiseling. Research teams worldwide have organized a blind testing protocol involving microcore samples from multiple H-blocks. These coded specimens, stripped of provenance, are analyzed independently through scanning electron microscopy, energy dispersive spectroscopy, and organic compound assays. Crucially, any organics uncovered will undergo accelerator mass spectrometry for radiocarbon dating, aiming to confirm their ancient origin and chronological alignment with Puma Punku's construction era between AD 536 and 600. The results will be fully transparent, with raw data and chain of custody documents published openly. Confirmation of the geopolymer casting theory would mark Puma Punku as the earliest large-scale example of this technology in the Americas, signifying a revolution in our understanding of pre-Columbian engineering and material science. If disproven, however, the enduring enigma of Puma Punku's stonework will persist, inviting further investigation. This evolving intersection of chemistry, archaeology, and technology challenges us to reconsider what might have been possible in an ancient world, where innovation lay hidden beneath dust and stone for centuries. The casting hypothesis transforms Puma Punku from merely a marvel of masonry into a potential milestone in technological history. Yet the story of discovery is far from over. As science embarks on this careful verification, the debate over Puma Punku's materials illustrates the broader challenge of interpreting the past through new lenses, reminding us that understanding ancient craftsmanship often requires blending tradition with cutting-edge research. Debate and verification process. The discussion surrounding Puma Punku's construction methods encapsulates one of the most fascinating modern debates in archaeology, a clash between established interpretations and emerging scientific insights. While the casting hypothesis offers compelling evidence, not all experts embrace it. Skepticism largely centers on the need for independent verification, given the extraordinary implications that would follow confirming such advanced ancient technology. A key step in establishing credibility has been the creation of a tiered evaluation rubric aimed at minimizing bias and maximizing reproducibility. The first tier considers visual evidence, tight joints, the absence of tool marks, and precise geometry traditionally used by archaeologists to assess craftsmanship. The second tier involves compositional analysis using tools like scanning electron microscopy and energy dispersive X-ray spectroscopy to detect unusual chemical compounds or structures. The highest tier demands blind, multi-laboratory replication. This involves dividing microcore samples from multiple H-blocks and sending them to various independent labs, none of which know from where the samples originated. Each lab conducts detailed chemical and organic compound analyses coupled with petrographic thin sectioning to test for consistency across results. Only if multiple labs detect similar signatures can findings be considered reliable. An especially critical component of these tests is radiocarbon dating of any organic binders found in the stones. This step directly links any discovered organics to the known historical timeline of Puma Punku, situated between AD 536 and 600. Validating this timeframe ensures that proposed geopolymer technologies were contemporary with the site's construction, rather than products of recent contamination. Transparency is a cornerstone of the verification process. All results, including both confirming and refuting data, are committed to full publication alongside detailed chain of custody records. This openness fosters trust in the scientific community and widens participation in the debate. It also holds particularly high stakes, given that confirming artificial stone production at Puma Punku would reshape our understanding of ancient Andean civilizations and global technological history. Meanwhile, proponents of traditional quarrying and carving methods argue that natural explanations remain more plausible without irrefutable physical evidence, such as molds or casting tools. They emphasize the extraordinary skill of Tiwanaku's artisans and caution against rushing revolutionary conclusions based on limited data. Highlights the complexity of balancing imaginative hypotheses with empirical rigor. The scientific process unfolding around Puma Punku exemplifies how archaeology increasingly embraces interdisciplinary tools, from chemistry and material science to computer modeling and machine learning. This convergence pushes the field beyond surface observations, allowing researchers to test hypotheses with unprecedented precision. It also introduces new challenges of interpretation and collaboration on a global scale. Ultimately, this debate is about more than Puma Punku alone. It reflects humanity's quest to understand how advanced ancient societies really were. Whether or not the casting hypothesis fully explains the H-block phenomenon, the rigorous scrutiny and innovative methods applied promise to deepen our appreciation for the ingenuity of past civilizations. Each new discovery and testing phase brings us closer to not only solving a remarkable architectural puzzle, but also honoring the true legacy of Puma Punku's builders, visionaries whose achievements continue to inspire wonder across the centuries. Implications for ancient technology. The revelations about Puma Punku's H-blocks have profound implications for how we understand ancient technological capabilities. If these massive stones were indeed cast rather than carved, it suggests knowledge of chemical processes and material science far ahead of what has traditionally been credited to pre-Columbian societies. This would position the Tiwanaku culture as pioneers of geopolymer technology, harnessing sophisticated methods centuries before similar techniques appeared elsewhere in the world. Such advanced mastery challenges long-held views of ancient engineering as primarily manual and labor-intensive. The idea that these builders manipulated stone at a molecular level speaks to a level of innovation that pushes us to reconsider assumptions about ancient peoples' scientific and artistic achievements. It calls for re-evaluating the scale of their ingenuity, moving beyond tools and brute force toward complex production techniques that rival modern masonry. Puma Punku's seismic-resistant design modular construction, and use of metal reinforcements combined with possible casting technologies illustrate an integrated knowledge system blending architecture, chemistry, and metallurgy. This holistic understanding hints at a civilization deeply interconnected with its environment and materials, capable of developing solutions tailored to its unique tectonic and climatic challenges. The potential discovery of geopolymer concrete use in Puma Punku also reframes the narrative about corporate memory and lost knowledge. It suggests that high technology can emerge, flourish, and then disappear, leaving behind enigmatic artifacts whose true origins require new methodologies and open-minded investigation to decode. Such possibilities inspire archaeologists and material scientists alike to expand their search for other examples of forgotten ancient technologies. Moreover, Puma Punku's engineered stones symbolize a union of technical skill and cultural expression. The precision and mathematical harmony embedded in the stone's design may reflect cosmological or symbolic meanings integral to Tiwanaku's worldview. Technology and spirituality were likely intertwined, with engineering serving not only practical needs but also ritual and political purposes. This intersection advances appreciation for pre-Columbian civilization's complexity, encouraging a shift away from simplistic or dismissive characterizations. It opens the door to recognizing that these societies were active innovators who contributed uniquely to humanity's technological heritage. Puma Punku becomes a testament to forgotten chapters in the global history of science and craft. The ongoing research into the site's construction methods stands as a call to integrate multidisciplinary approaches, combining archaeology, geology, chemistry, and digital modeling to unravel deeper truths. It reminds us that interpreting ancient ingenuity demands both rigorous evidence and openness to surprising possibilities beyond conventional frameworks. In this light, Puma Punku is more than an archaeological site. It is a beacon illuminating human potential across time. It challenges modern scholars to embrace humility when assessing ancient achievements and spurs continuous curiosity about humanity's inventive spirit. Ultimately, the story of Puma Punku underscores that technological innovation is not a linear progression, but a complex tapestry, sometimes hidden beneath millennia of history, waiting for new technologies and perspectives to bring it back to light. Puma Punku's H-blocks reveal a remarkable blend of ancient ingenuity, advanced engineering, and possibly lost technology. These discoveries challenge what we thought possible nearly 1,500 years ago and open exciting new avenues for research. If you enjoyed exploring these mysteries, don't forget to like and subscribe for more fascinating insights into our shared past.